All right, now we're gonna use the slope-intercept form to graph. So the first thing we need to do is make sure to write the equation in slope-intercept form, and then we're gonna graph the line described by the equation. So here, this is actually in slope-intercept form because the y is over here all by itself, and then we have our x here, and then our y-intercept out there. So the first thing we're gonna do is figure out what our m is. M equals 3, and our y-intercept is equal to -1. So when we graph the line, remember you always graph the y-intercept first. So we're gonna go make this -1. And then our slope, remember we need to make that a fraction, and that's the same as the rise over the run or the y over the x, okay? So from here we have our -1, and then we're just gonna go up 3, 1, 2, 3, and it's always from the y-intercept, okay? So once you graph that y-intercept, you're stuck in mud, and you only get released when you graph the slope from this y-intercept. So we're gonna go up 3, 1, 2, 3, and then over 1. And we can do it again. 1, 2, 3, over 1. And then we can also do the opposite, which would be down 3, 1, 2, 3, and over 1 this way. And why can we do that? Well, let's think about it. If we go down 3, we're going in the negative direction. And when we're going this way, we're also going in the negative direction. And what is a negative divided by a negative? Well, it is the same thing as +1. All right? So now that we have some points graphed, we can just go ahead and connect those dots. And we have our beautiful line, which represents this equation right here. Perfect. Let's go ahead and look at 3b. So for 3b, we have to write it in slope-intercept form. So is this in slope-intercept form? No, this is in standard form, right? So we have to write this in slope-intercept form first. And so the first thing we have to do is get y by itself. So I'm going to subtract 3x to both sides, and I end up with 2y equals, since we want slope-intercept form, we're going to write that x first, -3x plus 6. And then for slope-intercept form, when you're trying to get y by itself, when we divide by 2, we divide each individual thing by 2 because that helps us put it in slope-intercept form. So we end up with y equals -3 over 2x plus 6 divided by 6 divided by 2, which is 3. And so our slope is the number in front of the x, which is -3 over 2, and then our y-intercept is 3. So we're ready to graph. We go up to our y-intercept first at 3. We make a point. Now we're stuck, and the only way we can get unstuck is by doing the slope, which is the rise over the run. It's -3, so we're going to go down 3, 1, 2, 3, and then over 2, 1, 2. And there's our point right there. And now it's time to graph our line. Perfect. And that's it. All right, let's go ahead and look at another example. Okay, so for these 3A and 3B, I want you to try these ones on your own, okay? So where is my friend at? Oh, here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out those 2 problems. When you get done, press play, and we'll talk about them together. All right, see you in a bit. Okay, let's see how you did. So this equation here is already in slope-intercept form, which is perfect. So we don't need to do any algebra. We just need to define what is the slope. Well, it's the number in front of x, which would be 2/3. And then what's the y-intercept? Well, the y-intercept will be the number out here. Now there is no number out there, but there is. There is no number, but there is a number, and the number is 0. When there's nothing there, 0 represents nothing, okay? So we graph that y-intercept first of 0, and then from there we do the slope. Remember, it's the rise over the run, so it's the y over the x, right? So we're going to go up 2, 1, 2, and then over 3, 1, 2, 3. Or we can do the opposite, which would be down 2, 1, 2, and then over 3 in the negative direction, 1, 2, 3. And so there we have it. There's our line. We just connect the dots, and then, yeah. That's it. Okay, so if you got that right, awesome job. If not, go ahead and change so yours notes look like mine. All right, let's look at 3B. So we're going to write this line in slope-intercept form and then graph it. So is it in slope-intercept form? No, this is in standard form, so we need to put it in slope-intercept form. So we got to get y by itself, right? So we're going to subtract this 6x to both sides. I'm going to write the slope in the x first, because that's how slope-intercept form is, y equals mx plus b. But we don't have y by itself. There's a 2 in front of it, so we have to do the inverse operation of multiplication, which is division, and we're going to divide each thing individually, okay? So that means we end up with y equals -6 divided by 2 is just -3x plus 10 divided by 2 is 5. So our slope is equal to -3, but I'm going to write it as a fraction, which is -3 over 1. And that's our y over x, the change in y over the change in the x, which is the rise over the run, right? And then our slope is equal to 5. So we graph our slope first of 5. And then we are going to fall down 3, 1, 2, 3, and then over 1. And then we could do it again. 1, 2, 3 over 1, and we can do it again. 1, 2, 3 over 1. And there we go. Time to graph the line. Okay, right there. And make sure you put arrows on the end of the line, which just shows that it goes on and on forever. Forever and ever and ever and ever. All right, that is it. Let's go ahead and look at if you got that one right, awesome, awesome, awesome. Let's go ahead and look at the next examples here. So we're gonna go ahead and write this in slope-intercept form. This is already equal to y, so do you know how to graph this? Okay, so y is equal to -4. That means y is always equal to -4. There's nothing else, right? There's nothing else. That means y is always equal to -4. Well, when is y equal to -4? Y is equal to -4 right here, and 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 here. Y is always equal to -4 along this horizontal line. Uh-oh, I don't think I did that right on the dots. That's okay, so we'll just kind of make this a big horizontal line to cover up my mistake. So y, we can't even see the -4. That's -4. I'll do a little -4 with an arrow right there. Okay, y equals -4. So that's how you graph that one. What about this one? How do you graph this one? Okay, it says write it in slope-intercept form. All we have is x equals 2. Okay, so that's it. So you just write the equation like that. But how would we graph that? Think about, when is x equals 2? When does x equal 2? Well, x equals 2 here. It's along the x-axis, right? X equals 2 here, and here, and here, and here, and here, and here. So x equals 2 is actually a lovely, amazing vertical line. So whenever you see x equals something, right? X equals 10, then it would be a vertical line at 10. X equals -2, then it'd be a vertical line at -2. X equals -4, then it'd be a vertical line at -4. Whenever you see y, like y equals 1, then it would be a horizontal line at 1. If it was y equals +4, it'd be a horizontal line. So whenever something is y, that's going to be a horizontal line. Okay, and whenever something is equal to x, you know that that is going to be a vertical line. Okay, so just go ahead and commit those two things to memory. All right, that is it for this example. I will see you in a little bit for example 4.